Hello, in this video we are going to study the property of arithmetic mean, that is effect of change of origin and scale. In the previous video we have already discussed the rest of the properties of arithmetic mean. So let's first understand what is meant by effect of change of origin and scale. Simply, if we add or subtract a constant from each observation, then we say that origin is changed. And if each observation is multiplied or divided by some constant, then we said that scale is changed. So this is the statement for effect of change of origin and scale. If ui is equal to xi minus a upon h, then u bar is equal to x bar minus a upon h, where a and h are being constants. Here we have done subtraction and addition. It means we have changed the origin. And here we have done the division and multiplication. It means scale is changed. So first we will prove that how we get this step from that equation, and how we got that step from this equation. Okay, so we need to prove that how we get that from this step. So let's try to prove this. U bar is equal to nothing but summation of ui upon n. So what is value of n? We have given that xi minus a upon h. So in order to prove that statement, let me take 1 upon h outside the summation and 1 upon n inside the summation. So xi minus a upon n. I have just interchanged the denominator. So 1 upon h summation of xi upon n. I have taken summation inside the bracket and separate the numerator. So summation of a upon n. So 1 upon h inside the bracket, summation of xi is nothing but nx bar, according to the property of arithmetic mean. First property. And a is constant with respect to summation, because summation is varying from I is equal to 1 to n. So I can write summation a as na upon n. So nn will get cancelled. So I got the equation like x bar minus a upon this h. So this is nothing but ur. So if ui is equal to xi minus a upon h, then u bar is equal to x bar minus a upon h. Similarly, we will prove the second statement, that is yi is equal to c. If yi is equal to cxi plus d, then I need to prove that y bar is equal to cx bar plus d. In order to prove that statement, I will try to convert this yi to y bar. So how will I convert this? Let me take summation on the both side. So summation of yi is equal to summation of cxi plus d. So summation of yi is equal to, let's take the summation inside the bracket. So take the c is constant with respect to summation. So c summation xi plus summation of d. So summation of yi is equal to c summation xi plus d is constant with respect to summation. So I have written nd. Now I need to convert this summation yi into the y bar. So what will I do? I will divide by n on the both sides. So if I divide summation yi by n, then I will get obviously y bar according to the definition of arithmetic mean. So c times I want to divide by n, so c summation xi upon n plus n d divided by n. So summation of xi, so y bar is equal to c summation xi upon a is nothing but x bar plus n will get cancelled, so d. So from this statement we got this statement, that is if yi is equal to cxi plus d, then y bar is equal to cxr plus d. This is the way we have proved that statement. In this case we have done the addition, we have done the subtraction, we have done the addition, and we have done division, and even we have done multiplication. It means we have changed origin and scale both. So what if I want to change only the origin? Then what is the previous equation? Ui is equal to xi minus a upon h. In that case we have changed the origin and scale both. So if I want to change only the origin, then what will I do? Simply I will cancel out the h. So how will I cancel out the h? Simply I will take the h as 1. So h will get vanished. It means if we take h is equal to 1 in ui is equal to xi minus a upon h, then we get ui is equal to xi minus a. So what happened here? We have done here only subtraction. It means we have changed the origin only. So if ui is equal to xi minus a, then u bar is equal to x bar minus a. We can prove this statement like we have proved earlier. Okay. Similarly, if we take c is equal to 1 in the previous equation, that is yi is equal to cxi plus d, then we get yi is equal to xi plus d. Here we have changed the origin and scale both, because here we have done the multiplication and addition, but here we are doing only addition. It means we have changed the origin only. So if yi is equal to xi plus d, then y bar is equal to x bar plus d. In this both cases we have changed the origin only. Similarly, what if I want to change the scale only? So what will I do? I will put what is the original equation, ui is equal to xi minus a upon h. So if I want to change the scale only, then what should I do? I need to cancel out this a term. So how can I vanish this term? So simply I will take a is equal to 0, and in that equation I will take d is equal to 0. Then so if we take a is equal to 0 in ui is equal to xi minus h, and d is equal to 0 in yi is equal to cxi plus d, then we get ui is equal to xi upon h and yi is equal to cxi respectively. So here we have done only multiplication and division. It means we have changed only scale, not origin. So if ui is equal to xi minus h, then u bar is equal to x bar upon h. We can prove this statement like we have done already. So similarly, if yi is equal to cxi, then y bar is equal to cx bar. Here we have done, again I am repeating, here we have done only multiplication and division. It means we have changed the scale only. Here we have changed the origin, here we have shifted the origin only, because here we have done addition, here we have done addition and subtraction, and in that case we have done here subtraction and division, multiplication and addition. It means here we have changed the origin and scale both. So when to shift the origin, change the scale or change the both? So as per need of an example, we can shift the origin change the scale in amount, or change in origin and scale both. One more thing, let me explain the meaning of this statement. If ui is equal to xi minus a, then u bar is equal to x bar minus a. So what is the meaning of this statement? If I subtract some constant, in our case the constant is a. If I subtract some constant from all the observations, then new mean will also decreases by that constant, that is a. Okay. Similarly, if I add some constant, that is d, to all observations, then new mean will also increases by that constant, that is d. Similarly, what is the meaning of if yi is equal to cxi, then y bar is equal to cx bar? So if we multiply each observation by any constant, in our case the constant is c. If we multiply each observation, that is xi, by any constant, that is c, then new mean will be c times of initial mean. New mean will be c times of initial mean. Similarly, what is the meaning of if ui is equal to xi upon h, then u bar is equal to x bar upon h. Suppose if we divide all observation by some constant, that means if we divide the observations xi by the constant, that is h, then new mean will be initial mean divided by that constant, that is h. So let's have an example of effect of change of origin. Suppose the data is given in Celsius and we wish to switch it to degrees Kelvin. So the 0 degree Celsius is nothing but 273.15 kelvins. It means the origin is shift of about 273.15 degrees. A change of origin would be if you started counting or measuring at a different point. Here our initial point is 0. Since the 0 degree Celsius is nothing but 273.15, it means we have shift our origin about 273.15. Generally we consider the origin is the 0 on line. Let's have one example just for fun. So in that case I will try to prove the statement. Suppose my data is in degree Celsius, that is 2 degree, 4 degree, 7 degree and 3 degree. So the mean of these 4 observations is nothing but 4 degrees Celsius. But now I want to convert this data in kelvins. So the 2 degrees Celsius is nothing but 275.15 kelvins. Similarly, 4 degrees Celsius is equal to 277.15 kelvins, and so on. So if I find the arithmetic mean of these degree kelvins, then the mean is nothing but 277.15. And here the mean of this degree Celsius is nothing but 4 degree Celsius. Earlier we have seen the statement like if I add some constant to each observation, then in the in new arithmetic mean, the final old arithmetic mean plus that constant, that means in the final answer the new mean will also increased by that constant. You can see this in the example. Here each observation is increased by the 273.15 degrees. See, 275.15 minus 2 is nothing but 273.15. Similarly, each observation is increased by 273.15. So the final answer is also final answer is 4 degree in Celsius, and here our final answer is 277.15 kelvins. So here each observation is increased by 273.15. So the final answer is also increased by 273.15. Why this example is suitable for effect of change of origin? Because in order to convert the degree Celsius into the kelvins, we need to add some number to the degree Celsius. Therefore this example is suitable for change of origin. So similarly, let's have an example for change in scale. It would be measuring something in kgs instead of grams, then everything would be scaled down by a factor of about 0.001. Why this example is suitable for change in scale? Because 1 kg is nothing but 1000 of grams. It means here we are doing the multiplication or division in order to convert these measurements. So what was our statement about effect of change in scale? If ui is equal to xi upon h, then u bar is equal to x bar upon h. If we divide to the observation by some constant, then new arithmetic mean will be also old arithmetic mean divided by that constant. Let's have one example for fun. Suppose I have a data in grams, that is 1000 gram, 5000 gram, 4000 gram and 2000 grams. And the total is nothing but 12,000 grams. So the arithmetic mean of this data is nothing but 3000 grams. And now I want to convert that data which is given in grams, I want to convert it into kgs. So in order to convert that grams into the kgs, I need to divide by some factors, that is d is equal to 1000. So I need to divide by some constant, that is 1000. So 1000 divided by 1000 is 1. So I got the data in kgs like 1542. So the answer total is nothing but 12 and x bar is nothing but 3. It means if I divide each observation by some constant, then new mean also be the old mean divided by that constant. That means new mean is nothing but 3. How will I get that new mean? By dividing old mean by that constant, that is 1000. So I got 3. So now did you get the meaning of this? If ui is equal to xi upon h, if ui is equal to xi upon that h, that is 1000, then u bar, that is, this is nothing but u bar is equal to x bar upon that constant, that is h. So next is let's have example of effect of change of origin and scale. If we have a data in Fahrenheit and would like the mean to be in Celsius, then Celsius is equal to nothing but 5 upon 9 into F minus 32. Why this Fahrenheit into Celsius? This type of example is suitable for effect of change of origin and scale, because here we have done the both operation, like multiplication, that is we have done the change in scale, and we have done the subtraction, that is we have shift the origin. That's why this example is suitable for effect of change of origin and scale. So this is what the concept of effect of change of origin and scale with examples. In the next video we are going to see the examples like data based examples of effect of change of origin and scale. Thank you and bye bye.